Hello students of class 10 ICSE. So as you know, we have been talking about artificial intelligence and robotics curriculum code 66, and in particular we have made several videos on part 1, that is robotics. Okay, and today I'll be talking something different. So we will start the part 2, which is artificial intelligence. And as you can see, this is the syllabus. Here you also have Python programming later on. Now today I'll start this decision making in machines or computer, which is the first chapter. And this first chapter consists of 3 parts. First is automated versus autonomous system. Next, what is decision making, and finally you will learn about machine learning. So I'll be talking quite briefly, to the point, taking into account your upcoming examinations, right? So let's start. So basically we are going to talk about how machines make decisions, right? And for this, the very first thing we have to do is to understand the different types of systems which are out there. And in this regard, the very first thing again which I'll be talking is, mark my words, automated versus autonomous systems. So they look quite similar, both have auto in them, but they are very much different. Let's see. So what's an automated system? It is a machine which follows fixed pre-programmed instructions without thinking or adapting. Now pre-programmed means we have already programmed what the machine will be doing. That's your automated system. Okay, now think of a microwave oven. So suppose you press 2 minutes, then what happens? It just heats up for exactly 2 minutes, that is 120 seconds. So the machine will run for 120 seconds, not for 119 seconds, not for 121 seconds, exactly 120 seconds. Every time, without fail, no matter what's inside. Of course, electricity must be there, right? The machine should be working. That's a separate issue. Now, let us think about autonomous system. Now, what's the difference? You see, unlike the automated system, an autonomous system is a machine that can sense its environment. This is very important, this sense factor. Make its own decisions. Again, it's again very different. Make its own decisions, and then finally adapt to new situations. So it's an entirely different system. So what's an example? An example is a vacuum robot like Roomba that navigates around furnitures, avoids stairs, and finds its charging station when the battery is low. So if there is a kid out there who wants to disturb, the Roomba will immediately try to avoid the kid and try to do its chores. Okay, so what's the connection? The connection is that as systems become more autonomous, they need better decision making abilities, and this is where the machine learning comes in. Now the next stop is deterministic versus probabilistic system. Okay, again, what's deterministic system? Here basically the outcome is always predictable and certain. So same input means same output every time without fail. For example, a vending machine. If you press say B3, get chips, that's it, always. So B3 means getting chips in the vending machine. Now, unlike this deterministic system, we also have a probabilistic system where the system works with probabilities and likelihood. And here, unlike the previous case, outcomes can vary, and that is based on chances. So let's get an example. You see, your phone's autocorrect predicting the next word. Suppose you are trying to type something in your phone, in your laptop or something, you will always get some sort of suggestion. That's the autocorrection feature. Okay, prediction. Now it guesses based on probability, but of course it isn't always right. So suppose you are typing some word and you are just writing MA, there will be an autocorrection prediction like MAYUR, mayor. Okay, but suppose you are writing MAA, ma. So you see, it's not the real word that you are writing, but it gives suggestions. That's it. So what's the connection? The connection here is simple automated systems, you see, they are deterministic, whereas smart autonomous automated, right? Whereas smart autonomous systems often need to be probabilistic. Why? This is because our real world is unpredictable and the machine must adapt itself depending on the changing environment, changing scenario. Okay, now let's see how decisions are made. So the first thing is subjective versus objective decision making. So what's the subjective decision? Well, it's a choice based on personal feelings, opinions, experiences, or even preferences. You see, different people can make different choices for the same situation. Let's think of a human example. Well, someone says this painting is beautiful or this pizza tastes better than burgers. Of course, it depends entirely on the person's choice. Some other person can say something different. The painting might not look appealing. That person might say this pizza is not so good. That's it. It's a personal choice. Okay. Now, what about objective decision? So, unlike subjective decision, objective decision here is a choice based on facts, measurements, and data that anyone can verify. So, given the same facts, the decision should be the same. So, let's think of a machine example. This object weighs 2 kilograms or the temperature is 25 degrees centigrade. Now, there is data, of course, based on which we are saying this object weighs 2 kilogram or the temperature is 25 degrees centigrade. So, it does not matter who the person is. The person will just look at the data and will say, yes, it's correct. The object indeed weighs 2 kilogram or the temperature is indeed 25 degrees centigrade. So, what's the key insight? You see, humans naturally make both subjective and objective decisions, whereas machines are naturally good at objective decisions, but they struggle with subjective ones. And you see, machine learning, in fact, it helps bridge this gap. Okay, let us now talk about object classification, right, for humans and computers. Let us compare the cases. So let's say we need to identify some cats in photos. Now, what do you think? How you will classify object? You as a human being, right? How will you classify? You see, we recognize patterns instantly using our past experience. We can identify a cat even if it's sleeping, running, or partially hidden. And we even use intuition. I just know it's a cat, that's it. And of course, we are quite flexible and we can adapt to unusual situations. This is also important. Now, what about computers? What do you think? How do they classify objects? You see, they measure specific features like the ear shape, fur pattern, eye position, whisker count. And in fact, they need thousands of examples to learn what a cat looks like, because unlike us who have past experience, they don't have that much. So they learn through thousands of examples, and then they compare new images to patterns they have learned from training. Okay, and then finally they calculate probability, and they can say something like this: well, there is an 85% chance that this is a cat. So what did you learn, my students? Well, you see, computers, they turn subjective tasks like recognizing a cat into objective measurements, that is analyzing pixels, patterns, shapes. Okay, and this is the foundation of machine learning. Okay, so now we are ready to talk about machine learning, which is basically teaching machines how to learn, right? So what's machine learning? ML in short. Well, it's a method where computers learn to perform tasks by studying examples and finding patterns in data, rather than being given step-by-step instruction for everything. So you can think of it like learning to ride a bicycle. You see, no one can write down every tiny instruction. So how you keep a balance, how you pedal, what direction you move, you have to learn. Okay, so instead what you do, you try to practice. Of course you will fall down. Everybody has fallen down when trying to learn bicycling, right? So there is nothing wrong with it. That's the human way. And then you adjust and your brain learns this pattern. And you see, machine learning, it lets computer do something very much similar with data. Now in this regard, it's quite important to understand the role of data and information. So what's data? Data is effectively raw facts and numbers collected from the world. So let's look at an example. 100 photos of fruits, each with measurements of color, size, shape and weight. So what's information then? It's something different. It's meaningful patterns and knowledge which is discovered from organizing and analyzing data. So let me give you an example. Apples are usually round with a stem indent, and oranges have a bumpy skin. So see, this is information. So did you learn the connection? You see, more data means better patterns can be discovered, and this means we can have smarter machine learning, and as a result the machines will be making better decisions. Okay, so now let us talk about the steps in machine learning. Okay, now the first step is to collect data. Gather many examples like 1000 fruit photos. Next step is prepare the data. So you have to label the examples like this is an apple, this is an orange, and then organize them. And then the third step is model training. That is feeding data to the computer repeatedly so it learns patterns. And then you test, check if the computer has learned correctly using new examples it hasn't seen. And this is very much similar to students, how you learn in your school. So let's just think of the maths paper or math subject. So you learn from your school textbook, right? Or you might have your home book, and you learn say algebra basics, and you practice with it through exemplar problems and all that, and then you go to the exam hall, and in the examination you get questions, none of which is common to what you have learned, but they use the same principle of algebra. See, this is how a good examination is. So there is nothing different here as well. So in the test we are giving it new examples which it hasn't seen. So this is how we do machine learning. Machines are made to learn. So the next time you go to an examination and get some different type of questions, don't complain. There is nothing wrong with it. This is how it's supposed to be, right? So let's come back to our original topic, and the fifth step is deployment. So then we use the trained system to make real decisions. Now, let us talk about programming and algorithm quite briefly. So, what's an algorithm? You probably know this. Well, it's a step-by-step recipe for solving a problem, like a recipe for baking cookies. But this one is meant for computers. And then, what's programming or coding? So, it's basically writing instructions in a language which computers can understand. So computer language like Python, Java, C, C++, Fortran, right? Now, the thing is, why do they matter for machine learning? You see, we need instructions and computational thinking algorithms that can analyze data, find patterns and improve over time. And you see, good programming, good coding, what does it do? It basically makes machine learn more efficiently. So if you have a textbook which has got simpler concepts, no jumbled up, no unnecessary examples, simpler concept, you will learn more efficiently. Just like that. So you will say this is a good book. Just like the machine will learn efficiently through good coding, good programming. Right. So without this, you see, machines can't learn to make the subjective judgments that come naturally to humans. Now, let's look at a real example of fruit sorting machine. So what's the challenge? The challenge is, you see, a fruit company receives mixed boxes of apples and oranges. Good. And you see, workers are too slow to sort thousands of fruits per hour. So the question is, in this situation, can a machine really help us? Now, what's the old automated approach, which is the deterministic one? So basically the program, we have to program simple rules. Red color, the fruit should go to apple bean, or if the color is orange, the fruit should go to the orange bean. That's it. Now the problem is, we can have green apples. Yes. So what will happen to them? So green apples will get sorted wrong. And of course we can have reddish oranges. And that will even confuse the system. So this deterministic approach is quite rigid. You understand it, right? Now, next we have the machine learning approach, which is probabilistic and autonomous. So what's the approach? So basically, collect data, say photograph of 5,000 apples and 5,000 oranges. Of what? They don't have to be of the same type. You take the photographs of these fruits of all types of colors, sizes and varieties from all over the world, right? And then you prepare the data. You level each photo and measure features. What features? Color in multiple spots. So color at the various spots. Next, size and weight. Next, surface texture, whether it's smooth or dimpled. Next, shape roundness. Next, stem characteristics. And after that, you train the model. You show the computer all the 5,000 plus 5,000, that is 10,000 labeled examples. And then the algorithm finds patterns. Like apples often have stems and smooth skin. Oranges usually have dimpled texture even when greenish. Shape differences, oranges are more perfectly round. And then you test it. You show 2,000 new fruit photographs which was not there previously. New, okay. And then the system correctly identifies 98% of them if it's a good system, if it has learned, okay, through machine learning. So the question is how it decides. You see, when a new fruit arrives, the camera captures image. The computer measures all features and compares with the learned patterns and then calculates probability. So it's 92% confident this is an orange, something like this. It makes decisions and then sorts accordingly. So, of course, this is much better, right? Why? Why is it so? You see, the machine, it has learned to combine multiple object measurements like color, texture, shape to make a subjective judgment like, is this an apple or orange? Now, it's probabilistic. It gives confidence percentages and also autonomous, like adapts to fruit it hasn't seen before. So what's the connection? You see, this example basically it shows how all concepts work together. You see, the system is autonomous. It makes its own sorting decisions. It's also probabilistic. It works with confidence levels, not certainties. And this is something where a common person you will find if you go out there and talk. People don't talk in probabilities, they don't talk in confidence levels normally. They say, yes, I know this happens. I know means 100%. So if you ask, sir, is there a chance that you can be wrong? What rubbish are you saying? And this is normally out there. So if you hear something like this, don't get upset. They probably don't know much about probability, but you must learn. Okay, you don't say anything, you don't try to correct the person or whatever, but you must understand that this logic needs some rectification. Okay, now next, it makes objective measurements like color values, texture patterns, but solves a subjective task, right? Like what humans just know by looking. So basically we are using machine learning. Learn from examples, remember, not programmed rules. And this is all powered up by algorithms and programming. So basically we are having pattern recognition code. And if you talk about the details, so basically the machine has been trained on data. How much data? 10,000 fruit images, right? And then next 2,000 for testing purposes. And so basically we are able to extract useful information, the patterns that distinguish fruits. So my dear students, what's the key takeaways of this chapter? So you see, we have seen that systems evolve. So automated systems, they just follow rules. So from automated systems, now we have autonomous systems which make decisions depending on the scenario. And for this we need machine learning to get smarter. Okay, that's after that. Now we have also learned that decision types matter. You see, humans excel at subjective decisions. Machines excel at objective ones. And machine learning, it helps machine tackle the subjective problems. Now what about learning from data? You see, instead of programming every rule, we give machines examples and let them discover patterns. So what's the real world impact? You see, these technologies sort your photos, recommend videos, filter spam, and help doctors diagnose diseases. So there are so many applications out there, right? And the future indeed belongs to systems that can learn, adapt, and make increasingly complex decisions. So I think you have understood the entire point. Good. So if you have any queries or questions, do ask me.